Hello, my name is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada and around the world. This particular lecture is on translation of axis in regards to a parabola. The last lecture that I did was translation of axis with an ellipse. Now, they're basically the same sort of idea. Translation of axis just means that the center or the vertex is not at the origin. The origin is at 0, 0. When we look at what's written here, the center of the conical shape, which could be a circle, ellipse, in this case it's a parabola, that does not have its center or vertex at the origin, which is 0, 0. For parabolas, the standard form of the equation, if the center, if the vertex is at the origin, it would be this here. X squared is equal to 4px, where 4px is equal to the coefficient of the y value, right? So, and this one here, and it is y squared is equal to 4px now. Now, when we look at the y and x in here, this means that the line of symmetry is parallel to the y-axis, and this one means the line of symmetry is parallel to the x-axis. The non-squared term, this is the y is squared here, it's the non-squared that tells you which is parallel to the line, the x or y-axis, the non-squared term. When we look at this, the vertex is at the origin for this type of equation. How do I know that? I know that because we don't have h and k involved. H and k gives you the coordinate of the vertex of the parabola, right? We know that 4p is that coefficient that I spoke about previously. The standard formula. When we look at this, we're looking at, again, this guy here. That's written in a different form. The reason why this one has taken the shape is because of the vertex is at the origin, and these are the coordinate of the vertex. If you substitute 0 in there and 0 in here, you get exactly these formulas, right? So when we are looking at this, also I wanted to point out that the point x and y is a point on the parabola, and here we're looking at h and k as the coordinate of the vertex, the coordinate of the vertex of the parabola. So these explanation and these prep work that we're doing right now is for us to do some problems. The vertex is not at the origin. The line of symmetry passes through the vertex and the focus. Let's move to the next slide. And I have to click here first and then move to the next slide. When we look at this, we have plot the shape. We're given this particular shape here. And when I examine this, I know that this is a parabola because I don't have two square terms. If we had two square terms, we would more than likely be a circle or an ellipse, but because I have only one squared term, then I have a parabola, and it is in that particular form, right? It is in that particular form that these two equations are gonna fit, right? So we are looking at this. 4p is that coefficient right there. So I could tell you right now, if this is 4p, then p should be 1, and we'll see that right away. Now, and the focus. Let's see, plot the shape and the focus. So we want to plot the shape and the focus. So the focus always happens on the inside of the parabola. When we go and pull out the coordinate of the vertex, when you pull it out, it becomes a positive. When you pull it out, it becomes a positive. The reason for that is when you plug it in, it has a negative in the formula itself, so it changes the sign. So when you pull it out, you have to change that sign back, right? And the next thing that we know about this is that the line of symmetry is parallel to the x-axis. Well, how do we know that? The line is parallel to the y-axis. Sorry about that. The y-axis. How do we know that? It is the non-squared term, right? This one is squared, so the line of symmetry has nothing to do with it, but it is the non-squared term that reveals the line of symmetry, right? So that's how I know that. The other thing is, it opens positively along the y-axis, right? So if the line of symmetry is parallel to the y-axis and the line of symmetry cuts the parabola in half, then you're opening positively, because this term here, this one in particular, does not have a minus sign, right? If it had a minus sign, then we would be opening negatively, but we are opening positively. We know that 4p, right, according to the formula, 4p is equal to 4. So that's what I'm going to equate, and I'm going to get the distance. P is the distance from the vertex to the focus, right? P is the distance from the vertex to the focus. So I could equate this and solve it. P is equal to 1. Let's go and draw this up. We know that because of the coordinate of the vertex, I'm in the first quadrant because both of them are positive. I am in this quadrant here. I know my line of symmetry is parallel to the y-axis, so that line of symmetry is going down here somewhere. I'm going to plot my vertex, and then I'll put in my line of symmetry. I know that this is opening positive y, so it's going from here positive this way, right? I know also that my p-value is going to be on the inside, and it's going to be right about there. It will add 1 to that y value, so it'll be 3, and 6 is going to be my focus, right? And then I go and put in my parabola, and guess what? We got it done. We got it done, right? So let's see what else we have here. We are going into another problem. Again, it's asking for the shape and the focus. It's given. Now we have a minus sign in front of that, so we know wherever the line of symmetry is going, it's going to be opening minus to that particular axis. We could go and we know that our line of symmetry is going to be parallel to the x-axis because this is the non-square term. And then I'm going to go and pick out my vertex. I'm going to pull out my 5 and make it negative. It's on the y, so right there. And I'm going to pull out my x and make it positive. So I have my vertex. Okay. The other thing that I know from this is 4p is equal to this. Line of symmetry is parallel to the x-axis. We know that already. Opens negatively. Opens negative x, right? So we know that it's opening negatively because of this. And then we know that 4p is equal to minus 8. So if I were to solve for p, which is the distance from the vertex to the focus, it would be 4 divided into minus 8 will give you minus 2. So let's go and look at that. Just looking at this here, I'm not in the first quadrant, I am in the fourth quadrant more than likely, or the third quadrant, sorry about that. We're looking at 2 and minus 5. Okay, 2 and minus 5. I'm somewhere in here, the fourth quadrant. Let's go and put that in. I know that my line of symmetry is parallel to the x, so it's going this way. It's going this way, right? We know that it is opening negatively, so negative x. It's opening this way, right? We also know that p is minus 2, so we're going to have in the x direction, I'm going to have to subtract 2 from that. It'll get 0, so it'll be 0 and minus 5 is my focus. And let's go and put in a line of symmetry, put in our focus and our parabola, and we got this one done too. Okay, and let's go to the next one. Plot the shape and the focus. Same thing again and again and again. We are looking at our line of symmetry is going to be parallel to the y. We're looking at 12 is equal to 4p. We're looking at the vertex is going to be minus 3 and plus 1. So all of that just by looking at it and understanding what these numbers mean. We know that when we pull this out, it becomes negative. When we pull this out, it changes the sign, becomes positive. the line of symmetry is parallel to the y-axis because this is the non-squared term, it's y. Opens positively because this is positive right here, so it's going to be opening positive y. This value is for p, right? So if you solve for p, you're going to get positive 3. And then we are going to go and draw this thing up. I know because of this guy here, I'm going to be minus 3 and plus 1 somewhere about there. So let's go and put that in, right? And then I know my line of symmetry is parallel to the y-axis, so it's going to be running down here. I know it's opening positive y, so it's opening this way. I went and put in the focus first. Well, the focus is 3, positive 3, so it's going to go from here. The y is going to be the one that changes, and add 3 to that, you get 4. So the coordinate of that is there. And then we put that through those points. And now we have our parabola finished with. Let's go and see what's next. And again, of course, there's always another one. Find the equation of the curve through the vertex. Well, we know it's a parabola already, and the focus. So anytime you're given coordinate points, you should plot them up. A visual is very, very important. Anyhow, let's plot the points. Go and plot the points. And then we're going to put our line of symmetry through these points because we know it has to go horizontal, right? It has to go through the vertex and it has to go through the focus. So let's go and put that in. Now we know that this parabola is going to open from the vertex enclosing the focus. So we know that it's opening positive x, like that. Now it's the time to go and pick the equation that matches this. So we know the line of symmetry is parallel to the x-axis, so the x has to be the non-squared term. In this case, this is the equation that fits this description here. Line is symmetrical to the x-axis. We already know that. Open positively, we know that also. And p is going to be 4. How do we know that? The distance between here and there is p. So we know that it's in the x direction, minus 1. So we're going to go 1 unit, and then 3 unit will give you 4 unit. And that's how we got p. We've already picked the equation where the line of symmetry is the non-squared term. We're going to plug these values into this equation and come up with an equation for this parabola rather than just the format of the equation. And then when we go and do that, we plug the 3 in, it becomes a minus 3. We plug the minus 1 in, it becomes a plus 1. And then we know that this is plus 4, it's going positively, so we have 4 times 4 is 16 right there. We're going to go and place this in general form, and of course when we do that, we're going to multiply this out right there, and we're going to expand this binomial. Remember how to expand a binomial. You take the first term, you square it, product of the inside times 2 will give you the middle term, and you square the last term. And this will be 16 x plus 16. Again, you take the first term, you square it, product means multiplication, minus 3y times 2 minus 6y, and square a minus 3, it'll become plus 9. We have this as 16x plus 16. I'm going to take everything to the left hand side, both of these terms, and then I'm going to put it in descending power. Right, so when we look at that, the highest power is y squared. I'm going to put y beside it. I bring the minus 16 or plus 16x to the other side, it becomes minus 16, and then this plus 16 becomes minus 16, plus 9 will give you minus 7, and there is general form. Okay, so that's another one down the line. Let's go and look at something else. We are given now the coordinate of the focus and the equation of the directrix. Okay, remember what the directrix is. It's a line outside, on the opposite, outside of the vertex. It is on the outside of the vertex, and the distance between the directrix and the focus, which is this guy here, halfway in between there is your vertex. Okay, so let's go and plot these points up. We have the focus plot, we have the directrix plot. Halfway between here and here we have the vertex. Halfway. So when we look at the y direction, we know that from here to there is +3, and this is 5. 5 and 3 is 8. Halfway between 8 will be 4. So if you add 4 to this guy here, it'll give you -1, right? And that would be our vertex. Our line of symmetry is perpendicular to the directrix, and of course we put in our vertex. Right? So we know that this parabola is opening this way. It's opening that way. I don't know what this 0, 0 is doing here. It's supposed to be right there, but we'll deal with it. And we put in our parabola, and we're saying that the vertex is halfway between the directrix and the focus, so that was what was given. And we're looking at open negative y. So that's what it's doing. We're going to go and pick the equation now. We want to find the equation, find the general equation. So we want to pick, we know that the line of symmetry is parallel to the y-axis, so the y has to be the non-squared term, which is this guy right here, right? So that should match this right here. We're going to go and plug in the coordinate of the vertex. The +2 becomes -2, and the -1 becomes +1. We also know that P is this distance here. We calculated it already. We know it's 4, and it'll be -4 because it's going from the vertex to the focus. It'll -4. So you plug that in there. This will be -16, and there it is. We're going to expand this out. Square the first term, product of the inside, which is -2x times 2, give -4x, and then -2 squared is +4. And we're going to multiply this out, 16y, -16y, -16, right there. And then we are going to go and take everything to the left hand side, equal to 0, no fractions, right? You can't have any fraction in these things when we look in the general form anyhow. When we look at this, we have descending power. We have x squared minus 4x plus 16y. When you take that over to the other side, the -16y becomes +16y, and this becomes a plus as it goes over to the other side. We have +16 plus 4 plus 20, and you got it. You got it. And another one is bites the dust, as they say. Let's go and look at something like this now. We have a tunnel is in the shape of a parabola. The height of is 20 meters and the width is 20 meters. So you could look at it 20 by 20. Find the equation of the tunnel and the height 2 meters from the right hand side. So the right hand side, which would be 2 meters in from here, we want to find that height. Okay? Well, the first thing that I'm going to do with this is establish where the vertex is, and I'm going to put my origin right there. So I'm going to do that. It makes sense for me to do it right there. Then, when we look at line of symmetry, it'll be right through there. If we were asked to find a focus, it will be somewhere in there, but we're not asked to find that. We're asked to find the equation. Okay, find the equation right there. Right, we are asked to find the equation. We also know, because of the dimensions that are given here, this point, I'm going to go for this point rather than this point. This point is going to be half of 20, so it'll be 10 is the x value, and the y value will be -20. Right? So we have a point. Remember, in these equations, x and y represent a point on the parabola. Now we have a point. We could get a second point, but I would like to stay away from two negatives, right? I'll deal with one negative if I have a choice to do that. And the next thing that we have to do here is go and find the equation. Now, because this the vertex is at the origin, we could eliminate the h and k, or we could go and plug in 0 in there. It'll give us the same value anyhow. We know the line of symmetry is parallel. It is on top of the y-axis. On top of the y-axis. So which one of these equations will be used? Well, we'll use the non-squared one right here. So we're going to use that one. And x squared is equal to 4py. So if we substitute zeros in there for the vertex, we get this. Okay? Now, let's go and plug in our values. Right? Okay, solve for, let's go and solve for p first. We want the equation, so we have to find p. When we look at this, we're going to solve this equation for p, and to do that, I am going to divide out for y. So that's what I've done there, and that's where it is. Now I'm going to plug in for x 10, right? Because this is the point I'm using. I'm going to put in minus 20 for y. That's the point I'm using. So when I crunch the numbers on this, 10 squared is 100, and 4 times minus 20 is minus 80. I'm going to reduce that by dividing everything by 20, right? So I get that as my p. The equation say 4p, right? So that is my p. Let's go and look at the next step in this. We have the equation saying 4p, so we plug that in. X squared is equal to 4 times p times y gives us the equation of the line, and you can see that this cancels out with that. You have minus 5. So this is the equation of the parabola. Once you have the equation of the parabola, you find any one of the coordinate associated with that parabola, any one of the distance. The other part of this, find the equation of the tunnel and the height at 2 meters from the right. 2 meters from the right, so 2 meters in will be, x will be 8, right? So that's where I'm going to go and plug in x and solve for y. So when I'm looking at this 2 meters from there, I'm going to solve for y right there. So if I divide out the minus 5, that's what you get. Now, when we look at this point here, we have from here to here is 10, and we want 2 meters in, so that's why I laid it out like that. Yeah, that's why I laid it. It'll be 8, right? So we have 8 squared, which is 64 divided by 5 will give you, or minus 5 I should say, will give you minus 12.8. So when we look at this, everything in this is reference from the origin. So I am going 12.8 down. This is 20, the height of it. So 12.8 down I'm going to go. And then I'm going to go 2 over. So the idea of this is at 2 meters from the right hand side, I want to find that height there. How do I do that? Well, I take 20 and subtract 12.8. I'm going to get that height. So that's the last step that we have here. We have minus 20 minus a minus 12.8 will give you 7.2 meters. So at 2 meters here, 7.2 meters will be the height of the tunnel. And hopefully that makes sense to you, and I hope you gather some information from this. This is the last one from the conical section of our program, and we are going to go into some determinants and matrices. Not so much matrices, but determinants in our next section. So anyhow, you hang tough and hang in there. Bye-bye.